In number 9, it gets a little bit more complicated, but still along the same lines of what we've been doing. Difference with this, we're solving this differential equation, which we've been doing all through the notes, but here there's a y in there in our equation. So what needs to happen is what I was talking about before, but we haven't really had to do it, is separating the variables. Get the y's and the dy on one side, the x's and the dx on the other side. So up until now, it was always just like a dy equals something times dx. In this case, we've got a y in there, so we need to get things separated. Y's and dy's on one side, x's and dx's on the other. So basically in this one, we want to multiply both sides by dx to get the dx over here, and then we want to multiply both sides by y to get the y over here. Another way of looking at it is basically we're just cross-multiplying here. Right, if we cross-multiply, we get y dy equals 2x minus 3 times dx. So now they're separated. Once they're separated like that, we can do the antiderivative of both sides. Problems we saw earlier, it was always just 1 dy, so the antiderivative was just y. Here, it's a little different. What's the antiderivative of y? Well, this is like y to the first, right? So we have to add 1 to that exponent, so it's going to become y squared, and then we have to divide by that new exponent, or 1/2 y squared. Then over here we get x squared minus 3x plus c. So just like before, next step after we do that antiderivative, we want to figure out what's c. So we're given y equals 2 when x equals 4. And I don't want to plug that in for c. I'm going to plug that in for our x's. So 1/2 times 2 squared equals 4 squared minus 3 times 4 plus c. So 1/2 times 2 squared, we're just going to get 2 equals 16 minus 12, that's 4 plus c. So c is negative 2. So our equation that we have so far is 1/2 y squared equals x squared minus 3x minus 2. But we're not done. When we want to solve a differential equation, we want to get an equation for y. We want to solve it just for y, so it should be y equals. So we have a couple steps to finish off here. What's the first step to get y by itself? Multiply by 2. Right, so we're going to multiply both sides by 2. We get y squared equals 2x squared minus 6x minus 4. Then we want to get the y by itself, get rid of that squared, so we're doing the opposite of squaring and taking the square root. But when we do that in an equation when we're solving, we need to remember positive or negative, which gives us one last decision to make. It's got to be one or the other. Is our answer y equals positive square root of 2x squared minus 6x minus 4, or is it y equals negative square root of 2x squared minus 6x minus 4? And that decision depends on the point that we're given, the x and y value. If we look at these numbers, when we put 4 into this equation, we need to get 2 out. So if we were to put 4 into this equation for x, we'd have, we got that positive or negative out in front for now still. We have 2 times 4 squared minus 6 times 4, come on, minus 4. So we get 32 minus 24 is 8, minus 4 is 4, and we need that to equal 2. So we get square root of 4 under here. In order for that to equal 2, what sign do we need out in front? Positive, right? I mean, you don't actually have to plug that in to figure it out. Think about it. Our y has to be positive 2. Since y equals positive 2, our square root has to be a positive square root. Now, if this said y equals negative 2 when x equals 4, then our final answer would have to be the negative square root of that whole thing. But in this case, we're dealing with a positive square root of 2x squared minus 6x minus 4.